Finance. We have to work with money every day. While balancing your checkbook or calculating your monthly expenditures on espresso requires only arithmetic, when we start saving, planning for retirement, or need a loan, we need more mathematics. Simple interest. Discussing interest parts with the principal or amount your account starts with. This could be a starting investment or the starting amount of a loan. Interest, in its most simple form, is calculated as a percent of the principal. For example, if you borrowed $100 from a friend and agreed to repay it with 5% interest, then the amount of interest you would pay would just be 5% of $100. $100 multiplied by 0.05 equals $5. The total amount you would repay would be $105, the original principal plus the interest. Simple one-time interest. I equals P sub 0 multiplied by R. A equals P sub 0 plus I equals P sub 0 plus P sub 0 multiplied by R equals P sub 0 multiplied by 1 plus R. I is the interest, A is the end amount, principal plus interest, P sub 0 is the principal, starting amount, R is the interest rate in decimal form. Example, 5% equals 0.05. Example 1. A friend asks to borrow $300 and agrees to repay it in 30 days with 3% interest. How much interest will you earn? P sub 0 equals 300, the principal, R equals 0.03, 3% rate, I equals $300 multiplied by 0.03 equals $9. You will earn $9 interest. One-time simple interest is only common for extremely short-term loans. For longer-term loans, it is common for interest to be paid on daily, monthly, quarterly, or annual basis. In that case, interest would be earned regularly. For example, bonds are essentially a loan made to the bond issuer, a company or government, by you, the bondholder. In return for the loan, the issuer agrees to pay interest, often annually. Bonds have a maturity date, at which time the issuer pays back the original bond value. Example 2. Suppose your city is building a new park and issue bonds to raise the money to build it. You obtain a $1,000 bond that pays 5% interest annually that matures in 5 years. How much interest will you earn? Each year you would earn 5% interest, $1,000 multiplied by 0.05 equals $50 in interest. So over the course of 5 years, you would earn a total of $250 in interest. When the bond matures, you would receive back the $1,000 you originally paid, leaving you with a total of $1,250. We can generalize this idea of simple interest over time. Simple interest over time, I equals P sub 0 multiplied by RT. A equals P sub 0 plus I equals P sub 0 plus P sub 0 multiplied by RT equals P sub 0 multiplied by 1 plus RT. I is the interest, A is the end amount, principal plus interest, P sub 0 is the principal, starting amount, R is the interest rate in decimal form, T is time. The units of measurement, years, month, etc., for the time should match the time period for the interest rate. APR, annual percentage rate. Interest rates are usually given at an annual percentage rate, APR, the total interest that will be paid in the year if the interest is paid in smaller time increments. The APR will be divided up. For example, a 6% APR paid monthly would be divided into 12 0.5% payments. A 4% annual rate paid quarterly would be divided into 4 1% payments. Example 3. Treasury notes T-notes are bonds issued by the federal government to cover its expenses. Suppose you obtain a $1,000 T-note with a 4% annual rate, paid semi-annually, with a maturity in 4 years. How much interest will you earn? Since interest is being paid semi-annually twice a year, the 4% interest will be divided into two 2% payments. P sub 0 equals $1,000, the principal. R equals 0.02, 2% rate per half year. T equals 8, 4 years equals 8 half years. I equals $1,000 multiplied by 0.02 multiplied by 8 equals $160. You will earn $160 interest total over the 4 years. Compound interest. With simple interest, we were assuming that we pocketed the interest when we received it. In a standard bank account, any interest we earn is automatically added to our balance, and we earn interest on that interest in future years. This reinvestment of interest is called compounding. Suppose that we deposit $1,000 in a bank account offering 3% interest compounded monthly. How will our money grow? The 3% interest is an annual percentage rate, APR, the total interest to be paid during the year. Since interest is being paid monthly each month, we will earn 3% divided by 12 equals 0.25% per month. In the first month, P sub 0 equals $1,000, R equals 0.0025 multiplied by 0.25%, I equals $1,000 multiplied by 0.0025 equals $2.50. A equals $1,000 plus $2.50 equals $1,002.50. In the first month, we will earn $2.50 in interest, raising our account balance to $1,002.50. In the second month, P sub 0 equals $1,002.50. I equals $1,002.50 multiplied by 0.0025 equals $2.51 rounded. A equals $1,002.50 plus $2.51 equals $1,005.01. Notice that in the second month, we earned more interest than we did in the first month. This is because we earn interest not only in the original $1,000 we deposited, but also earn interest on the $2.50 of interest we earned the first month. This is the key advantage that compounding of interest gives us. To find an equation to represent this, if P sub M represents the amount of money after M months, then we could write the recursive equation. P sub 0 equals $1,000. P sub M equals 1 plus 0.0025 multiplied by P sub M minus 1. You probably recognize this as the recursive form of exponential growth. If not, we could go through the steps to build an explicit equation for the growth. Observing a pattern, we could conclude P sub M equals 1.0025 raised to the M power multiplied by $1,000. Notice that the $1,000 in the equation was P sub 0, the starting amount. We found 1.0025 by adding 1 to the growth rate divided by 12, since we are compounding 12 times per year. Generalizing our result, we could write P sub M equals P sub 0 multiplied by 1 plus R divided by K raised to the M power. In this formula, M is the number of compounding periods, month in our example, R is the annual interest rate, and K is the number of compounds per year. While this formula works fine, it is more common to use a formula that involves the number of years rather than the number of compounding periods. If N is the number of years, then M equals NK. Making this change gives us the standard formula for compound interest. Compound interest. P sub N equals P sub 0 multiplied by 1 plus R divided by K raised to the NK power. P sub N is the balance in the account after N years. P sub 0 is the starting balance of the account, also called initial deposit or principal. R is the annual interest rate in decimal form. K is the number of compounding periods in 1 year. If the compounding is done annually, once a year, k equals 1. If the compounding is done quarterly, k equals 4. If the compounding is done monthly, k equals 12. If the compounding is done daily, k equals 365. The most important thing to remember about using this formula is that it assumes that we put money in the account once and let it sit there earning interest. Annuities. For most of us, we aren't able to put a large sum of money in the bank today. Instead, we save for the future by depositing a small amount of money from each paycheck into the bank. This idea is called a savings annuity. Most retirement plans, like 401k plans or IRA plans, are examples of savings annuities. An annuity can be described recursively in a fairly simple way. Recall that basic compound interest formula follows from the relationship P sub m equals 1 plus r divided by k multiplied by P sub m minus 1. For a savings annuity, we simply need to add a deposit D to the account with each compounding period. P sub m equals 1 plus r divided by k multiplied by P sub m minus 1 plus D. Taking this equation from recursive form to explicit form is a bit trickier than with compound interest. It will be easiest to see by working with an example rather than working in general. Suppose we will deposit $100 each month into an account paying 6% interest. We assume that the account is compounded with the same frequency as we make deposits unless stated otherwise. In this example, R equals 0.06, 6%, K equals 12, 12 compounds, deposits per year, D equals $100, our deposit per month. Writing out the recursive equation gives P sub m equals 1 plus 0.06 divided by 12 multiplied by P sub m minus 1 plus 100 equals 1.005 multiplied by P sub m minus 1 plus 100. Assuming we'd start with an empty account, we could begin using this relationship. Continuing this pattern after m deposits, we've saved P sub m equals 100 multiplied by 1.005 raised to the m minus 1 power plus 100 multiplied by 1.005 raised to the m minus 2 power, and so on, plus 100 multiplied by 1 plus 005 plus 100. In other words, after m months, the first deposit will have earned compound interest for m minus 1 months. The second deposit will have earned interest for m minus 2 months. Last month's deposit would have earned only 1 month worth of interest, and so on and so on. Annuity formula. The annuity formula is P sub n equals D multiplied by 1 plus r divided by k raised to the nk power minus 1 divided by r divided by k. P sub n is the balance in the account after n years. D is the regular deposit, the amount you deposit each year, each month, etc. R is the annual interest rate in decimal form. K is the number of compounding periods in 1 year. If the compounding frequency is not explicitly stated, assume there are the same number of compounds in a year as there are deposits made in a year. For example, if the compounding frequency isn't stated, if you make deposits every month using monthly compounding, K equals 12. If you make your deposits every year using yearly compounding, K equals 1. If you make your deposits every quarter, use quarterly compounding, K equals 4, etc. When do you use this? Annuities assume that you put money in the account on a regular schedule, every month, year, quarter, etc., and let it sit there earning interest. Compound interest assumes that you put money in the account once and let it sit there earning interest. Compound interest, 1 deposit. Annuity, many deposits. Payout annuities. In the last section, you learned about annuities. In an annuity, you start with nothing, put money into an account on a regular basis, and end up with money in your account. In this section, we will learn about a variation called a payout annuity. With a payout annuity, you start with money in the account and pull money out of the account on a regular basis. Any remaining money in the account earns interest. After a fixed amount of time, the account will end up empty. Payout annuities are typically used after retirement. Perhaps you have saved $500,000 for retirement and want to take money out of the account each month to live on. You want the money to last you 20 years. This is a payout annuity. The formula is derived in a similar way as we did for savings annuities. The details are omitted here. Payout annuity formula. P sub 0 equals D multiplied by 1 minus 1 plus R divided by K raised to the negative NK power divided by R divided by K.